Hi, Chapter 2, Math Definition of a Strain. A closer look to a strain. If we want to have a closer look to a strain, so if you take this element out of a whole structure and study in terms of a strain is nothing but change of length over original length. But if we want to have a more closer look to a strain, that's the mass definition of a strain. In a strain definition, displacement are not important, but deformations are. In other words, one can say in a strain definition, relative displacement are important. So by deformation, we can easily imply relative displacement. So in a strain definition, relative displacement are important to us. Let's see what relative displacement is. So if you consider this figure, AB, bar AB or line AB lies in x direction with the length of dx, and line AC with the length of dy, it's located in y direction. If B moves to B prime and C moves to C prime, let's see what's happened in terms of strain. So note, in a stress calculation, we do consider the stress element, but in a strain, we consider the thread. So when we were observing the calculation, we calculating the stress, we would create or observe the element and its part. But what we do for a strain, we don't go for the element, we just go for the thread. So what that means is, if you're considering, we call that this part from here to here is delta xx, from here to here is delta xy, and let's say, and this is delta yy, and this is delta yx. Let's see how that goes. So delta xx, the first one shows the thread along x direction, so that's delta x, and if you look at the second terms, it just shows you the rotation. So from B to B prime, it just rotates toward the y-axis. So the second one is y. So definitely the first one has no rotation, so remains by x. Likewise, this is delta yy, the thread is in y direction, and there is no rotation, just go for y. And the other one, again, thread is in y direction and just rotates toward x. The second one shows that one. Now if you want to see what the relative displacement is, delta xx over dx is called relative displacement of thread along x direction. Likewise, delta yy over dy called relative displacement of thread along y direction, and delta xy over dx called is equal to tangent of delta xy, and if the angle is pretty small enough, the tangent of any angle would be equal to the same one, the same angle, and that called by shearing strain at x direction. Likewise, delta yx over dy called shearing strain at y direction. And the addition of delta xy plus delta yx called gamma xy, and that's again in the nature of shearing strain, but this time at 2D. Each of them was in one direction, 1D, and addition of both of them comes to gamma xy, and that's shearing strain in at xy plane, so in a 2D condition. So Again, if we want to say the normal definition of a strain is delta over L, epsilon xy plus epsilon yx is equal to gamma xy equal to gamma yx. And if you create a strain tensor in 2D, it just gives you epsilon x, epsilon y, and a half of gamma xy and a half of gamma xy over here. Again, back to Hooke's law. Hooke's law is sigma is equal to E times epsilon. Hooke's law in shear is gamma is equal to G times tau is equal to G times gamma. Let's solve a problem with the concept of a strain definition, mass definition of a strain. So it just gives you shows a rectangular plate is deformed into the shape shown in dashed line. So it's deformed from normal shape A, B, C, D to the new shape. So D goes to D prime and B goes to B prime. Determine the normal strain along the diagonal BD. So the solution is if we draw the initial diagonal and then the new diagonal of B prime, D prime. We want to see what is the change of BD to BD prime. What is that ratio, which is the normal strain along diagonal BD. So the approach for that is from geometry. The diagonal BD is pretty simple. It's nothing but a square of 300 square plus 400 square, which are the AD and the AD square plus BD square, and that's nothing but 500 millimeters. But after applying the after deformation, if you look at to B prime, length of B prime D prime, that is a AD prime, and that's 300 plus a positive 2 here minus 2 here. So it moves up by 2 millimeters, but at the same time the other side comes up by 2 millimeters. So that's the concept of relative displacement. So if you gain 2 bucks at the end of the day and you lose 2 of them, it means the turnover is nothing. So this is 2 at D and this is minus 2 at B to B prime, plus the, if you look at the other direction, that's 400 plus a increase of 3 millimeters at B, and at the same time relative displacement is important, and a minus of 2, so that gives you 401. And if you calculate the numeric value of that, that's L B prime D prime is equal to 500.8 millimeter. Again, in other words, in a strain definition, relative displacement are important. That's the application of relative displacement in our problem solving approach. If you want to see what happened in X direction and Y direction to the thread from B to B prime, there is an angle of, we call that phi, and that phi is a rise of 2 millimeters over a run of 403. So that gives you this amount in radian. And if you want to see what happened in Y direction, again from D to D prime, this is D, this is D prime, there is again an angle, we call that alpha in Y direction, and that's nothing but an increment of 300 plus 6 minus 2. So that's I'm talking about here. So there is a 6 millimeters minus 2 relative, you have to subtract that. So the original length was 300, so that's a change of from here to here. This is 6, this is 3. 6 minus 3 is 3, comes here. On denominator you have original length in y direction plus 6 minus 2, that's 3 over 304, and that gives you this angle in radian. And gamma bxy, gamma for b in plate of xy is nothing but phi plus alpha, and that's 0.0148 in radian. And a simpler approach for solving this problem is a line of cosine, a law of cosine. If you consider a to b prime and d prime, and if you go by cosine law, it just gives you ab prime plus ad prime minus 2ab prime times ad prime times cosine of the two angles. Just be careful, the original angle was 19 degree and there is a small deviation from 90, so that's 90 minus arctangent of 2 over 302 minus arctangent of that's the 2 over 202. It just comes from here. So rise over run 2 over 302 minus arctangent of, again, rise over run 2 over 403, and if you subtract that from a 19 degrees angle, it just gives you a smaller angle of 89.32. So b prime d prime is 579, which is almost the same with the first value of 508. By subtracting 508 minus 500 over original value of 500, you can easily get the strain of diagonal. Thank you.